All right, this is going to be the second part of applications of systems of equations. The last video, we covered all this. And today we're going to go ahead and do the backside. The backside is only going to be two different types of problems, or two different problems and one different type of problem. We're only going to be doing combination of items. So let's go ahead and do yourself a favor. On the backside, copy, press pause on the video, copy all that down. I'm going to assume you already did that, and we're just going to go ahead and jump right in. So type number 4 is going to be combination of items. So remember, there's 4 steps to doing this. Step number 1 is going to be to define your variables. Step number 2 is going to be to come up with your system. Step number 3 is solve the system. And then step number 4 is finally answer the question. All right, so let's see. It says Bill ordered 5 chicken wings and 4 chicken tenders and paid $14.25. Ted ordered 3 chicken wings and 2 chicken tenders and paid $7.75. What was the cost of the wing? Notice that in both of them, they gave you two different things that were being purchased as well as the total. And they didn't say anything like, oh, there were 4 more chicken tenders than twice the amount of wings or something like that, right? So it wasn't, even though it kind of sounds like it, it's not really this one. Like it has part to do with this one. But they didn't have like your group purchase 25 tickets total, right? They're telling you stuff that associated with the price and the total and then with the price of the total again. So both of your formulas are actually going to look like this, okay? So that's exactly what we're going to do. But before we do that, we need to define our variables. What is the question asking me? The question is asking me what the cost of the wing was. So do I know how many wings were ordered? Yes, I do know how many wings were ordered. 5 chicken wings for Bill and then 3 chicken wings for Ted. So I'm not going to say let W represent, the number of wings because I know how many wings were ordered. The question is asking what was the cost of the wing. So this time I don't know the cost, right? A little bit different than the previous one. So let me go ahead and I normally you're going to say, oh, how come you're not using the letter C, right? Well, because it's chicken wings and chicken tenders. They're both chicken. So I'm going to go with W for wings and T for tenders because I don't know how much either of them have cost. So I'm going to say let W represent the cost of the wing. And again, I don't know how much a chicken duck tender costs, so I'm going to say let T represent the cost of a tender. I mean, this is not mandatory, but notice that my T for tender, I wrote it a little bit different than the T for let. Because I want to use T as a variable, I make my T cursive, or not cursive, but just stand out a little bit different with that little loop at the end. So that way, if I want to write like plus T, it looks like this. I know that this is a plus and this is my variable T. And this doesn't say T plus, right? If I want a T plus, notice my variable has that little curve at the end and my plus doesn't have the curve. Just so it's a little bit easier for me to know when am I using a T and when am I using an addition sign, okay? That's just a little trick. All right, so I want to know W is the price of the wing, T is the cost of a tender. Now that I have this, let's go ahead and start writing down my formulas. It said Bill ordered 5 chicken wings and 4 chicken tenders, and he paid a total of $14.25. So 5 chicken wings. How much is 5 chicken wings going to cost? Well, I know I'm buying 5 of them, but I don't know how much each chicken wing costs, and that's why I called it 5W. Remember, this time W represents the price of the wing. So maybe it's $2 per wing, and that'd be like 5 times 2 would be $10 that he paid, right? Just on wings. But he didn't buy just wings, he also bought chicken tenders. How many chicken tenders did he buy? He bought 4 of them. And how much was each chicken tender? I don't know, so I'm going to call it 14. So that says 5W plus 14. Notice the plus and the T, a little bit different. Equals, when he bought 4 wings and 4 chicken tenders, he ended up spending a total of $14.25. All right, so that's my green formula for Bill. Now I'm going to go ahead and do the other formula for Ted. It said Ted ordered 3 chicken wings and 2 chicken tenders and paid a total of $7.75. So this is going to be for Ted 3 chicken wings, 3 wings plus 2 tenders, 2T equals, and in this case it paid, $7.75. That should be in pink as well. All right, 7.75, and we get that right there. So that's going to be my pink formula. I'm going to take a look at the two formulas, and it looks like I should probably use elimination on this one, right? Hey, on these problems, especially with these decimals, go ahead and use a calculator for these, right? Like the problems are hard enough. I don't want you stressing on like, oh, the decimals and positives and negatives. So you should be using a calculator on these problems. Hey, I can't add these. Well, first of all, they're lined up, so I'm going to be going ahead and using elimination in this. If I try to add them right now, they're not going to cancel. So I'm going to take that bottom equation and multiply it by -2. That way I can get the t's to cancel. So I'm going to multiply this by -2, this by -2, this by -2. What do I end up with? I end up with 5w plus 4t equals 1425. And on the bottom, I end up with -6w minus 4t is equal to 1550, negative 1550, excuse me. And again, just use a calculator on that and you should be okay. All right, let's go ahead and add up these variables. Let's see, it looks like these t's are going to cancel, which is exactly what I want. I'm going to go ahead and add 5w with -6w. I get -1w is equal to, and then if I add these one, it should be -1.25. If I divide both sides by -1, I get w is equal to 1.25. Now, normally I would say you can't buy 1.25 wings, but remember, W does not represent how many wings. W represents the cost of a wing. So that means the cost of each wing that he purchased is $1.25. And that's exactly what I was looking for. So I don't need to find the second part of this answer. They're just asking me for the price of the wing. So I can say the price of each wing is $1.25. All right, we're done with the first example, and we're almost done with this. We're almost done with the notes because we're down to our last one. All right, it says 2 soccer teams went to Burger Hut after the game. The first team ordered 12 burgers and 9 hot dogs and spent $58.50. The second team ordered 15 burgers and 7 hot dogs and spent $66.75. What was the cost of one burger? So again, do I know how many burgers were bought? Yes, I know how many burgers. What I don't know is the cost of each burger. So I'm going to say let B represent the cost of each burger. All right, so I got B. What else did they buy? They also bought hot dogs. So I'm going to say let D represent the cost of each hot dog. Okay, I define my variables. Let's go ahead and start coming up with equations. Let's see, the first sentence that might give me an equation is that the first team ordered 12 burgers and 9 hot dogs, and what they end up spending was $58.50. So just like the previous question, 12 burgers. I don't know how much each burger cost, but I know they bought 12 of them. So I'm going to say 12B. Now that's how much money was spent on just burgers, right? $12 for each burger, and then plus They also bought 9 hot dogs, so I'm going to say 9D. That's how much they spent on hot dogs, and when I put them together, it should be a total of $58.50. That is my green equation. For my second equation, or my second team, they ordered 15 burgers and 7 hot dogs. And they ended up spending $66.75. How do I write that? Well, 15 burgers, that's going to be 15B, plus 7 hot dogs, that's going to be 7B. And they spent a total of $66.75. That's going to be my pink equation. Now that I have my equations, I'm going to go ahead and try to check. Should I use substitution or elimination? Man, I'm going to be honest with you. I mean, the obvious answer is you should be using elimination, but man, is it hard to get a number that they both match up with. So when it gets kind of hard to find out the number, right? Like it's hard to see what 12 and 15 match up to. Like I know the answer is 60, but that might be kind of tough for some of you guys. And for 9 and 7, like if they both match up to, what you can do is you can actually multiply them by the opposite number, right? So you see 9 and 7, well, multiply those together. 9 times 7 is 63, right? Same thing with 12 times 15. The problem with 12 times 15 is that number gets really big. You might not know what 12 times 15 is. So we probably don't want to use that one. So let's go with 9 and 7. 9 times 7 is 63. I'm going to try to change those into 63s. How do I change the top one into 63? Well, for the 90, I'm going to multiply everything by negative 7 because remember, I need one of those numbers to be negative. And I forgot to write. Let's put a little thought bubble right here. We're going to be using elimination. Again, neither option is really good in this case. But I think between the both of them, I would probably go with elimination. So on the top, I'm going to try to get a negative 63 for the 9D, and I can do that by multiplying everything by negative 7. Remember, you're using your calculator, so this shouldn't freak you out too much. Let me go ahead and do that right now, because even I need my calculator on this one. So I know the first one's going to be negative 84B. And then the next one is going to be, you know what? Let me just check. I don't want to do this problem all just because I did it in my head. 12 times negative 7 is negative 84. That's correct. And then obviously the other one is going to be negative 63D equals, and I definitely need a calculator for this one. Let's see. This is 5850 times a negative 7. And that gives me negative $409.50. All right, on the bottom, I want to end up with a positive 63. And in order for me to end up with a positive 63, I need to multiply that 7 by positive 9. So everything on the bottom is going to get multiplied by positive 9. 15 times 9, I think it's 135. Let me just check. 15 times 9 is 135. B plus 63D equals, and then that one I definitely need a calculator for. So let's see, 66.75 times 9 gives me $600.75. I know those numbers are ugly, but it doesn't matter because we're using calculators. It should be okay anyways. I'm doing this because the D's are going to cancel. Those are gone. 135 plus a negative 84, or negative 84 plus 135. Let's see. 135. When I do this one, I end up with a positive 51B is equal to, and let me go ahead and add up the negative 409.50 with the 600.75. Negative 409.50 plus 600.75, and I get 191.25. We're going to go ahead and divide both sides by 51. These are going to cancel. I get B equals, oops, sorry, I lost my number. 191.25 divided by 51, 3.75. And again, just like on the last one, we're not worried about how many burgers, right? I know how many burgers. B does not represent how many burgers. B represents the cost of each burger. So each burger is going to be $3.75. They're asking me what was the cost of each burger? Oh, I'm already done. Okay, each burger cost $1.75. I'm sorry, $3.75. All right, guys, that's all the notes for today. As always, if you have any questions, please feel free to ask.